Today we are studying 4.3 Real Zeros of Polynomials, Day 2. We are looking at Descartes' Rule of Signs, which is finding the maximum number of positive zeros and the maximum number of negative zeros. What we are doing with Descartes' Rule of Signs is looking for the number of sign changes from one coefficient to the next, going from left to right. To find the positive real zeros, the number of positive real zeros, we would use the polynomial and look for the number of sign changes. To find the number of negative zeros, we are going to plug in negative x and then simplify. And the number of positive or negative zeros is either equal to the number of sign changes or is less by an even whole number. And what I mean by that is if the polynomial has 6 sign changes, then the number of zeros would be 6, 4, 2, or 0. So it can decrease by 2's all the way down to 0. If the polynomial has 3 sign changes, then the number of zeros would be 3 or 1, again decreasing by 2, but this, because it's an odd number, only goes down to 1. Now don't forget, the total number of possible zeros is equal to the degree of the polynomial. So the maximum number of zeros for the polynomial in all is equal to the degree. So let's look at this example. We have p of x equals x to the 8th minus x to the 5th plus x to the 4th minus x cubed plus x squared minus x plus 1. To find the maximum number of positive zeros, we just take the polynomial itself and we are going to count the sign changes here. So here we've got a positive for the coefficient here. This is minus, so that's a negative. We're adding x to the 4th, so that's positive. Subtracting, we're adding x squared, subtracting x, and adding 1. So every single time we go from one term to the next, we have a sign change. So we've got 1 there, 2, 3, 4, 5, and 6 sign changes. So 6, 4, 2, or 0, we'll put or 0, possible positive zeros. Okay, now for the negatives, we plug in negative x. When we look at negative x to the 8th, that is going to be positive x to the 8th, because an even exponent is going to make it positive. An odd exponent will keep a negative negative, but we have two negatives here making it positive or plus x to the 5th. Negative x to the 4th, again, is going to make it positive. We're adding, so x to the 4th. Negative x cubed, that stays negative, but we have two negatives there to make it positive x to the 3rd. Negative x squared is the same as positive x squared, so that's plus x squared. Negative x, we have two negatives in a row to make that a positive x, and then plus 1. So if we look here, that's the first term is positive, and then each term after that is also positive. So we have absolutely no sign changes, which means we have no negative zeros. And what that does for us is helps us to understand the number of zeros for each positive and negative. So if I'm doing my synthetic division and trying to find my zeros, I know not to test any negative zeros because there aren't any. So I will stay with all positive zeros and work from there. Okay, now let's talk about upper and lower bounds. While testing the positive rational zeros, use synthetic division. If all the numbers that turn out at the bottom of the synthetic division problem If they turn out to be positive, then the tested value is an upper bound, which means all the zeros are less than that number. If the numbers turn out where the signs alternate, then the tested value is a lower bound, meaning all zeros are greater than that number. So let's look at this example. Show that all the real numbers, or all the real zeros of the polynomial p of x equals x to the fourth minus 3x squared plus 2x minus 5 lie between negative 3 and 2. So no numbers to the left, or I'm sorry, no negatives less than, no zeros less than negative 3, and no zeros greater than positive 2. So let's do some testing here. We have negative 3. The 1 will come straight down, and negative 3 times 1 is negative 3. We're going to add, and we get negative 3. Now, again, negative 3 times negative 3 is 9. We're going to add, and we get 6. So far, we are alternating. So let's see what happens. 6 times negative 3 is negative 18. We add, we get negative 16. Negative 3 times negative 16 is 48. We're going to add and get 43. So the fact that all of these are alternating signs, so these are alternating, so negative 3 is the lower bound. Okay, now let's test the 2. If we bring down the 1, 2 times 1 is 2, 0 plus 2 is 2, 2 times the 2 is 4, add negative 3 plus 4, we get 1, 2 times the 1 is 2, we add, we get 4, 2 times 4 is 8, when we add here we get 3. These all are positive, which means that 2 is an upper bound. Okay, so that tells us that when we're testing our zeros, not to use numbers less than 3 and not to use numbers greater than 2. All right, let's look at this example. Find the integers that are the upper and lower bounds for the real zeros of the polynomial. So we need to use our P over Q ratio. So we're using the factors of 2 and the factors of 12 into this ratio. The factors of 12 are positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 4, positive and negative 6, and positive and negative 12. The factors of 2 are positive and negative 1 and positive and negative 2. When I list all my possible combinations, I will get 1 over 1, so positive and negative 1 over 1, and also 1 over 2, so positive and negative 1 over 2. Now we go to the 2, we get positive and negative 2 over 1, and then 2 over 2, so positive negative 2 over 2. We keep going, so we get positive negative 3 over 1, positive negative 3 over 2. Then we move to the 4, positive negative 4 over 1, and positive negative 4 over 2. Now the 6, positive negative 6 over 1, and positive negative 6 over 2. And now the 12, positive negative 12 over 1, and positive negative 12 over 2. Now when I look at this list, I have positive and negative 1, positive and negative 1 half. I have positive negative 2. 2 over 2 is the same thing as 1, so I can cancel that out. Now I also have positive and negative 3, positive and negative 3 over 2, positive and negative 4. 4 over 2 is the same as 2, so I can cancel that out. I have positive negative 6, positive negative 6 over 2. That's the same thing as 3, so cancel that out. Then I have positive negative 12, and 12 over 2 is the same as 6, so I can cancel that one out. So we do not need to duplicate our any zero, possible zeros. Now we're trying to find our upper and lower bounds. So basically now what we need to do is just test these numbers to see what works. And you might want to start with, you know, I wouldn't usually think that 1 would be an upper bound, but it could be. So you could test 1. I'm just going to choose 1 in here and see what works. Um, so let's see if -1 is a lower bound or even an upper bound. So -1, if I plug in the coefficients of my polynomial, I have 2, -3, -8, and 12. Okay, I drop down the 2, I get -2. When I add, I get -5. I multiply, I get 6. When I add here, I get -2. Well, I could already see that these are not all positive, and I'm not alternating anymore because I got 2 negatives in a row. So I could stop right here because we don't have, they're not all positives, and these are not alternating. So let's try something else. If we try -2, I have 2, -3, -8, and 12. If I bring down a 2, I get -4, then I get -7, and then I get 14, then I get 6. So far we are alternating. Then I get -12, and I get a 0. So I found a 0, which is fine. So I know my lower bound is definitely less than -2. So I'm going to try -3. I'll even write 0 here so I remember. So -3, if I try that, 2, -3, -8, and 12. Bring down the 2, multiply, I get -6, add, I get, it's supposed to be a -6, add, I get -18. When I multiply here, wait a minute, I multiplied the 6 and the 3. Okay, let's start this over. So bring this down, I get 2, multiply, I get -6, add, I get -9, I multiply here, I get +27, I add, and I get 19. When I multiply here, I get -57, and when I add here, I get -45. So these are alternating, which means that -3 is a lower bound. LB. I'm just going to put lower bound. Okay? Now I have found the lower bound. Now let's look for an upper bound. Um, since my exponent is 3, I have a 0 at -2. My lower bound is -3, so I've definitely got to go above 0. I'm going to give myself a little bit of flexibility, and I'm going to go ahead and try 3. So let's try 3. And I have 2, -3, -8, and 12. I'm going to bring down the 2. I multiply, I get 6. Add, I get 3. 3 times 3 is 9. I add, I get 1. 3 times 1 is 3. And I get 15. Hey, look at that. So I got all positives, which means this is my upper bound, UB. I'll put. So now I have found my upper bound and my lower bound. 3 is my upper bound, and -3 is my lower bound. So just looking at this list, if I know that -3 is my lower bound and +3 is my upper bound, then I really only have, you know, these values right here to be tested for my zeros. And I could ignore all the other ones. Oh, I guess I need to put in that positive and -3 halves because that's less than 2. Okay, so it cut my list in half anyway. Okay, so what do I have down here? All right, we got another example I'll write up. So that's actually it for the notes for day 2.